Welcome to the video for the third problem on the second exam. In this one, we have a very straightforward torsion problem. We need to calculate the polar moment of inertia, the torsion required to cause a particular rotation, and the shear stress that would cause. For the third problem, we had a very straightforward torsion problem where we have a length of 22 inches. We have an outer radius of 3 inches and an inner radius of 2.5 inches, and we are given the shear modulus. In this case, in this version, 6,000 KSI. So the first portion of this is asking what is the polar moment of inertia? So that is going to be pi over 2 times 3 inches to the fourth minus 2.5 inches also to the fourth, and that's going to be 65.88 inches to the fourth. I think probably just about everyone got that one right. Part B is a little bit more involved. It says that we've got a rotation. Let's change colors for part B. We've got a rotation equal to 0.2 radians at one end relative to the other. And the question is, what is the torque required to cause this? So we have the equation given in our notes that the rotation is equal to T times L. Very cool that I wrote L when I meant T, divided by JG, which of course we can rearrange to make T is equal to the rotation times the polar moment of inertia times G divided by the length, which in this case is going to be 0.2. J, you said, was 65.88 inches to the fourth, 6,000 KSI, over the length, which we said was 22 inches. And that's going to give us a torque of 3,593.2 kip inches. And now we have the question of, when we're subject to that torque, what is the shear stress that we're experiencing? Well, the shear stress equation that we've worked with works fine here. Torque times the radius divided by J. In this case, the torque we just calculated was 3,593.2 kip inches. We multiply that by our radius. The maximum is going to be 3 inches. Divided by the polar moment that we calculated was 65.88 inches to the fourth for this one, giving us our maximum shear stress of 160 3.3 KSI. So that was problem 3. It was very straightforward. So let's move on to problem 4.